Good morning. In this session, we will study about some of the applications of Biot law. We have studied about Biot law, and we know that it helps us to find out the magnetic field due to a current carrying conductor. Now in this class we will see about magnetic field due to steady current in an infinitely long straight conductor. We have a straight conductor which is very long, infinitely long. Now let us consider an infinitely long conductor. Let me say this is an infinitely long conductor, and carries current I. Let the conductor carries current I. Now for this reason, what we do is, let us consider a small current element, say dl. dl is the small current element. First we will find out, due to dl or due to this current element, what is the magnetic field at some point P, and the P is at a distance r from the current element. Let me repeat. A long straight conductor carries a current I. For easy derivation, we take a small current element, say dl, and using Biot law we can find out what is the magnetic field at P due to this current element, and point P is at a distance r from the current element. And let us say the angle between the current element and the distance vector is theta. According to Biot law we have, according to Savart law, we can write the magnetic field at P due to current element dl is magnetic field at P due to current element dl is given by dB equal to, only the magnitude I am writing, dB is equal to mu naught by 4 pi ideal sin theta divided by r square. Now this is the magnetic field due to a small current element dl. But our aim is to find out magnetic field due to the long straight conductor, infinitely long straight conductor. Now we know the magnetic field due to this small current element. By adding these small current elements, we can find out what is the magnetic field due to infinitely long straight conductor, or we can integrate. For that reason, we will do a small derivation. Now let us draw a perpendicular from P to this straight conductor. This is 90 degree. and let this angle as angle phi. Let the normal drawn from P to the straight conductor makes an angle phi, and let the distance of this point from the current element is L, and let the distance from this point, that is from this, the length of this perpendicular is E. Now let me say this angle is phi 1, or I will draw another line, and let me say this angle is phi 1 and this angle is phi 2. Angle phi, and phi 1 and phi 2 are point P to the end of the conductor. Now we have here dB in terms of IDL and sin theta by r square. Now let us rewrite this equation so that we can integrate from phi 1 to phi 2. We have to integrate from phi 1 to phi 2 to find out what is the total magnetic field due to the whole conductor, because from P, if I draw a line downwards to the end of the conductor, I have taken this makes an angle phi 1. Similarly, on the other hand, it makes an angle phi 2. So here, sorry, phi 1 should be the angle from this point, okay? So from P, phi 1. So this is phi 1, phi 2. For that reason, we will try to write this equation in terms of phi. All replace whatever is possible, like r, dl, sin theta, everything in terms of phi. Now sin theta, from figure we can write what is sin theta. Sin theta is opposite side divided by hypotenuse. So sin theta is opposite side is A. Theta is here, angle theta is here. So sin theta is opposite side, that is A, divided by hypotenuse, that is R. Sin theta is A by R. Or in another way, A by R, A is by R can also be written as equal to cos phi. Cos phi, because from the figure, if you see A by R, from the figure cos phi is, because just from this figure, what is cos phi? If you see phi is angle here, cos phi as adjacent side, that is A divided by hypotenuse, so A by R. Sin theta is equal to cos phi. We got in one equation, sin theta equal to cos phi. Call this as equation number 1. So in this equation I can replace sin theta by cos phi. Now next is, we will try to find out what is dl and r. From this itself I can write cos phi is here, I will write A by R. Therefore R is A by cos phi. R is A divided by cos phi. Remember, we are replacing all terms like dl sin theta r by in terms of cos phi. We are writing in terms of cos phi. So r is a divided by cos phi. Now we'll try to find out what is dl. From the figure, I can also write tan phi. What is tan phi? Tan phi is opposite by adjacent. Tan phi is opposite side, that is L. Adjacent is A. L by A. Tan phi is L by A, or L is A tan phi. Or differentiating, I can get dl as A tan phi is, differentiation of tan phi is secant square phi d phi. dl is A secant square phi d phi. Now substitute all these equations, like I will write here 3. Substitute equation 1, 2 and 3. Substituting equations, or using, we can write using equation 1, 2 and 3. Equations 1, 2 and 3. Using these equations, now we can write dB equal to mu naught by 4 pi I, and we have IDL. DL is this, A secant square phi d phi. Ideal sin theta. Sin theta is cos phi divided by r square. R is A by cos phi. A divided by cos phi whole square. Now here we can cancel few of the terms. One by cos square phi is secant square phi, so that will cancel with this, and 1a get cancelled with 1a, so only 1a remains. Now dB becomes equal to mu naught by 4 pi into I, 1a also cancel here, I mu naught by 4 pi into I cos phi d phi divided by A. Now this is the magnetic field due to the current element dl. Therefore magnetic field due to whole conductor is obtained by integrating the above equation from minus phi 1 to minus phi 1 to plus phi 2. Now remember, here you see the picture. So GL is here. So if I consider this end as, making an angle phi 2 and the other end makes an phi 1, from this end to this end, the whole conductor, that can be obtained by taking this whole angle. So integrating the equation from minus phi 1 to phi 2. Why minus phi 1? Because here I am taking in the anti-clockwise direction. Remember, the minus phi 1, the negative sign came because here we are taking the angle phi 1 from this point. P is in the anti-clockwise direction. Magnetic field due to whole conductor is obtained by integrating the above equation from minus phi 1 to plus phi 2. Now let us integrate. So total magnetic field B is equal to integration of dB from minus phi 1 to phi 2. dB, which is equal to integration of minus phi 1 to phi 2 mu naught by 4 pi into I cos phi minus phi 1 to phi 2 mu naught by 4 pi I cos phi into d phi divided by A. B is integration minus phi 1 to phi 2 dB, which is equal to minus phi 1 to phi 2 mu naught by 4 pi I cos phi d phi divided by A. And remember, negative sign came because we took phi 1 as an angle in the anti-clockwise direction. In the next session, I will show you how to derive this, and then also for an infinite long conductor, what is the value of phi 1 and phi 2. So those things we'll take up in the next session.